Assalamualaikum. We are from Group Testing Safety Critical Systems from Chapter 4, Testing the System. These are the group members. I myself, Tuan Alia Nabila, as the presenter, Muhammad Azmi as a quality check, Nuri Izzati as the presenter, Muhammad Nazmi is the one who recorded the video, Nur Anati, Afi as presenter, Nur Anati, and Muhammad Naim as the one who did the slide as well as the content, and Muhammad Imran and Muhammad Fikri also the presenter. First is introduction. Safety critical systems is a system whose failure or malfunction can severely harm people's lives, environment, or equipment. It is widely used in several fields such as medicine, transport, aviation, industrial simulation, and etc. It also consists of hardware and software, and both of them need to be secure to ensure the whole system is secure. Next is the definition. It is used all part of existing legacy software testing techniques. In addition to the existing testing techniques, we have to supplement some special techniques in order to minimize the risk and hazard associated with safety of software and environment. The beside are the quotes from the Lauren. When testing software at different stages of its development, tests are always performed to verify correct behavior against specifications, not against observed behavior. Next is process involved.
In process involved, the testing, safety, and critical system, there are two important factors that distinguish legacy software testing techniques from safety critical testing techniques, which are the degree of rigor and organizational structure. The degree of rigor is the amount of formality involved in testing a system, and organizational structure is the independent verification, which is required in the systems by means of a separate team within the overall project, or a verification team supplied by an external company who may not ever see the development team, depending on the criticality of the system. There are three techniques, which is the probabilistic risk assessments, PRA, failure modes and effect analysis, FMEA, and fault tree analysis, FTA. First, we look at probabilistic risk assessments, PRA. PRA is a systematic methodology to evaluate risks associated with a complex engineering technologies entity, such as airliner, or a nuclear power plants. In PRA, we need to perform a primary hazard analysis to find out the predefined hazard on safety critical system. The severity levels can be classified as catastrophic, hazardous, major, minor, and not safety related. And the probability of occurrence can be classified as probable, remote, extremely remote, and extremely probable. And the assessment of risk is calculated by combining both impact and probability of occurrence in metrics. Next, the figure shows the process for probabilistic risk assessments until the decision making. Next, we'll present about the failure modes and effect analysis, FMEA.
So the next techniques for testing and verifying safety critical system, which is FMEA, failure modes and effect analysis. This is a procedure for analysis of potential failure within a system for classification by severity or determination of the effects of this failure on the system. And this FMEA can be defined as any errors in a process, design, or item, especially those that affect the customer and can be potential or actual. And effect analysis refer to studying the consequence of this failure. Failure modes, effects, and criticality analysis, FMEA, is an extension to this procedure, which includes criticality analysis used to chart the probability of failure against the severity of their consequence. So the bottom have, on the left, we have FMEA map. And on the right side, we have potential causes and their effects. And next, we have the third techniques for testing and verifying safety critical system, which is FTA, fault tree analysis. FTA is a graphical techniques that provide a systematic description of the combination of possible occurrences in a system, which can result in as a failure. And this undesired effects is taken as a root of the tree of logic. Each situation that could cause the effect is added to the tree as a logic expression, and the events are labeled with actual numbers about the failure probability. And the probability of the top level event can be determined using mathematical techniques. And why we should use the FTA? FTA can be used to understand the logic leading to the top event, show compliance with the system safety, prioritize the contributor leading to the top event, monitor and control the safety performance, minimize and optimize resources, assist in designing a system, function as a diagnostic tool to identify and correct causes of the top event. Next. So this is one of the example of FTA. Here we have the failure event A as a top level failure event. This is a broken down, it will broken down into possible contributory failure events. And under it, we have OR symbol, means that event A happened when one or more event B, C, or D happens. And then failure event D, we have under it, we have N symbol, means that event D happens only when both event E and event F happens. Next. So this is the second example. The failure for this, we have the doorbell failed to ring. And for this example, we have only the or symbol. Next, I will pass to the next presenter.
Okay, now I will present about a case study. This case study is about failure modes and effect analysis and fault tree analysis based. Sorry. This case study is about failure modes and effect analysis and fault tree based software safety analysis of a railroad crossing critical system. The software is hazardous if it can cause a hazard that causes the other components to become hazardous, or if it is used to control a hazard. Software is deemed safe if it is impossible, or at least highly unlikely, that the software could ever produce an output that would cause a catastrophic event for the system that the software controls. None of the fault removal techniques like algorithm analysis, control flow analysis, pattern analysis, reliability plot diagrams, need circuit analysis, inventory analysis, ITMEA and FTA can be considered appropriate and complete in all respects when used in isolation. The way out of this is to analyze how to combine individual techniques so that the fault removal process is significantly improved. One of the most effective combination is failure modes and effect analysis (FMEA) and fault tree analysis (FTA). This paper proposed a system-level approach to software safety analysis for critical systems that combines two existing fault removal techniques, failure mode and effect analysis and FTA, to identify and eventually remove software faults at successive software development phases. So next, I will pass to the next presenter.
Thank you, Muhammad Imran and other presenter. I will continue Muhammad Imran present about the ROCS. Sorry for the spelling mistake here. For the RCCS software function, the safety analysis of RCCS software function takes place in three sequential steps. The first step is software failure mode and effect analysis, SFMEA. This analysis is performed in order to determine the top events for lower level analysis. SFMEA will be used to identify critical functions based on the applicable software specification. The second step is software fault tree analysis, SFTA. After determining the top level failure events, a complete software fault tree analysis shall be performed to analyze the faults that can cause those failure. This is a top-down technique that determines the origin of the critical failure. And the last sequential step is evaluation of results. The evaluations of the results will be performed after the above two steps in order to highlight the potential discrepancies and prepare the recommended corrective measure. Next. Here we have example of SFMEA tables for the RCCS. The failure mode here is gate not closed as train is passing through, and the possible cause is sensor not detected by software. Gate motor mechanism is defective, software give wrong command, and lastly software give right command at wrong time. The effect of this failure mode is train collisions with passing road traffic leading to accidents. The severity of risk for this failure mode is critical, and the prevention and compensation is software first checks the working status of gates each time the train is about to cross the gates. Next. Here we have the software fault tree analysis. As we can see here, in this fault tree analysis, all the event is OR, and as we know, the possible cause for this event is sensor not detect, and it happen when sensor broken or the train sensor interface disconnect. That's all from our group. Thank you.